It is saying x here, but we have theta here. So solve for theta, then change all this to theta. Solve for theta, where theta is between 0 and 360. So let's do part A right here. Solving these three equations. Let's do part A right here. So part A says to solve sine square theta equals 0.75. So first thing you have is sine squared theta is equal to 0.75. So first thing we're going to have to do is square root both sides. If you square root both sides, that would give you that the sine of theta is equal to, work out what is the square root of 0.75. The square root of 0.75, when I square root 0.75, I'm going to get two answers. I'm going to get plus or minus, and then I look at it, the square root of 0.75 is root 3 over 2. So I get plus or minus root 3 over 2. Now that this is what I get, plus or minus, that means I want the solution in all four quadrants. I want the solution in all four quadrants. I want the solution for here, 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 and here. All right? So first thing I need to do is find sine inverse of root 3 over 2. So sine inverse of root 3 over 2. When we work out sine inverse of root 3 over 2, what we are going to get is, you find sine inverse of root 3 over 2, and you get sine inverse of that is 60 degrees. So we get 60 degrees. Now remember, we want the answer in all four quadrants. So that means theta is equal to your angle in the first quadrant, which is 60 degrees. Then we need your angle in the second quadrant, which is 180 minus 60. 180 minus 60, which is 120 degrees. Then we need the angle in the third quadrant, which is 180 plus 60, which is 240 degrees. And then we need the angle in the fourth quadrant, which is 360 minus 60, which is 300 degrees. So those are all the possible answers. 60, 120, 240, 300. If you don't believe, check it out. You can check them out. You can go to your calculator and work out the sine of, let's start from 60, sine of 60. Make sure you put a degree sign, the sine of 60 degrees, and then you're squaring it. Try to write it better. You want the sine of 60 degrees, then we're squaring it. Look what happens. Sine 60 square, you get 0.75. There we go. You can change it 60 degrees to 120. You're still going to get 0.75. There we go. Still get 0.75. You can change it to your 240. Still get 0.75. You can change it to the 300. Still get 0.75. So that is how we solve that type of trig question. That question we had to square root first, And we had to remember that when you square root sine, you get plus or minus. So part A, you have to remember when you square root, you get plus or minus. Easy question, solved with a capital T. Let's look at part B now. Part B says to solve 1 minus tan square theta equals 0. Let's do part B right here. We still have enough space. So if you're solving 1 minus tan square theta, 1 minus tan square theta, you're solving this equal to 0. Then you can make tan square the subject. Bringing it over, you get tan square theta is equal to 1. And if you get tan square theta is equal to 1, you can square root both sides to get that the tan of theta is equal to, when you square root 1, you get plus or minus 1, plus or minus 1. So when you draw your circle, because you want plus or minus 1, you want when tan is in all the quadrant, you want positive tan, which is here and here, and you want negative when tan is negative, which is here and here. So first thing is we find tan inverse of 1. When you find tan inverse of 1, that's going to be your angle in the first quadrant, tan inverse of 1, and we know tan inverse of 1 is pi by 4. Tan inverse of 1 is pi by 4. Pi by 4 or 45 degrees. The angle in the first quadrant is 45. So that means theta is going to be equal to angle in the first quadrant, which is 45 degrees, angle in the second quadrant, which is 180 minus 45, which is 135, angle in the third quadrant, which is 180 plus 45, which is 225, and an angle in the fourth quadrant, which is 360 minus 45, which is 315 degrees. That's what we get. Nice and easy, soft. That's how we do this question. Nice. Now let's look at part C. Part C is to solve 4 sine theta equals sine theta tan theta. 4 sine theta equals sine theta tan theta. 4 sine theta equals sine theta tan theta. So we're solving 4 sine theta. I'm going to use x in this case. 4 sine x equal to, what was that again? 4 sine x equal to sine x tan x. Equal to sine x tan x. So if we're solving this question, first thing I want you to notice is that both of them have sine x. So what we're going to do is, since both of them have sine x there, what I'm going to do is I'm going to bring everything to one side. So I'm going to bring over to one side. So what I'm going to get is, if I bring over this side, I would get 4 sine x minus sine x tan x, that's equal to 0. Now since both of them have a sine x, I can factor out a sine x. So what I'm left back is 4 minus tan x equals 0. Now, if you have the product of two things equals 0, then that means either sine x equals 0 or 4 minus tan x equals 0. If sine x equals 0, we can solve this by drawing our circle for this one. And we know that sine is positive here and here. And we know that sine inverse of 0 is 0. And so then the angle in the second quadrant is 180. So from this part of the question, the two possible answers we get are x equals 0 or x equal 180 degrees. Those are two possible answers from this side. All right. Now from this side, what we're getting is, we're getting tan x equal 4. And if tan x equal to 4, we can draw our circle right here. Drawing our circle, what we end up get is tan is positive in the first and the third quadrant. And so we just need to find tan inverse of 4. Tan inverse of 4. Tan inverse of 4, we know that it is equal to tan inverse of 4 at 75.9 degrees. Let's call that 76 degrees. And so that means the angle in the third quadrant, so we're going to get x is equal to the angle in the first quadrant of 76 degrees, or the angle in the third quadrant, which is 180 plus 76 degrees. So 180 plus 76 degrees is 256 degrees. So those are our possible answers for x. 0 degrees, 180 degrees, 76 degrees, or 256 degrees. Those are possible answers. So x equal 0, or x equals 76 degrees, or x equal 180 degrees, or x equal 256 degrees. Nice. That's our answers. Nice. And you can check it. You can check them. Let's look at part D. Solve sine theta times 4 cos theta minus 1 equals 0. Sine theta times 4 cos theta minus 1 equals 0. So we're solving sine theta, let's call it sine x. Sine theta times 4 cos theta, or 4 cos x minus 1 equal to 0. So what we can do is we're solving this equals 0. So we're solving sine x equal to 0. Or we're solving 4 cos x minus 1 equal to 0. Now we already know the solution from this part from the previous question. X equals 0 or x equals 180. So let's go to this side. Solving 4 cos x minus 1 equals 0. We're getting 4 cos x equal 1. Then when we divide both sides by 4, we're solving cos x equal to a quarter. If cos x is equal to a quarter, we can draw our circle. Draw your circle and tick where cos is positive. Cos is positive in your first and your fourth quadrant. Cos is positive in your first and your fourth quadrant. So first thing you need to do is find cos inverse of a quarter. Find cos inverse of a quarter, and that will give you your angle in the first quadrant. So cos inverse of a quarter, that is 75.5 degrees. So you get 75.5 degrees. So to find your equivalent angle in the second quadrant, in your fourth quadrant, it's going to be 360 minus 75.5. 360 minus 75.5 degrees, which is equal to 360 minus 75.5, which is 284.5. This is 284.5 degrees. And so now we get all our answers for x. All right, we get all our answers for x. And so x is equal to 0 degrees, or x is equal to 180 degrees, or x is equal to 75.5 degrees, or x is equal to 284.5 degrees. Those are all our possible values for x. 0 degrees, 180 degrees, 75.5 degrees, or 284.5 degrees. Easy. Soft. Let's look at part E now. Part E says to solve 2 cos theta minus 1 times cos theta plus 1 equals 0. We're going to call theta x just for now again. 2 cos x minus 1 times cos theta minus 1. Let's do this. we're solving this right here. All right, we're solving this right here. Now, if you're solving something equals 0, then it's either you're solving this part equals 0, you're solving either this part equal to 0, or you're solving that part equals 0. That's what happens. Yeah, man, so is this part equals 0 or that part equals 0? If this part is equal to 0, then we just need to make cos theta the subject. Making cos theta the subject, we would get cos theta equal to a half. From this side now, if we make cos theta the subject, we get cos theta equal to -1. That's what we would get. So now, what we do now is we draw our circle, and we draw our circle, and cos of theta equal a half. All right, so where is cos positive? Here and here. All right, that is where cos is positive, here and here. So what we need to do is find cos inverse of a half. And so we find cos inverse of a half, and that will give you your angle in the first quadrant. So finding cos inverse of a half, what do we get? Cos inverse of a half, that is 60 degrees. And so the angle in the fourth quadrant is going to be 360 minus the angle in the first quadrant, which is 300 degrees. So that's the angle in the fourth quadrant. So a part of the solution we're getting so far is that theta is equal to 60 degrees. That's one possible answer for theta. And another possible answer for theta we're getting is 300 degrees. Now let's go ahead and find the possible values for theta on this side. So we draw our circle over here, and look where cos is negative. Cos is negative here and here. But we need to find cos inverse of 1. Cos inverse of 1 is equal to, I believe that is 0. Let's verify that. Cos inverse of 1. Yes, cos inverse of 1 is 0. So that means the angle in the second quadrant is going to be 180 minus 0, which is 180. And angle in the third quadrant is 180 plus 0, which is 180. So that means that from this side, theta equal 180 degrees. So combining your two solutions, what we're getting is the possible values for theta are theta equal 60 degrees, or theta equal 180 degrees, or theta is equal to 300 degrees. So theta is 60 degrees, 180 degrees, or 300 degrees. Nice and easy, soft. All right, let's move right along. Let's look at part F. Part F says to solve 2 cos squared theta minus sine theta minus 1 equal to 0. So we're solving 2 cos squared theta minus sine theta minus 1 equal to 0. 2 cos squared theta minus sine theta minus 1 equal to 0. Let's call it x. So this last one here, we're solving 2 cos squared x. Just to make it a little easier on us, 2 cos squared x minus the sine of x minus 1 is equal to 0. If this is what we're solving, first thing we need to do is we need to rewrite cos squared in terms of sine. So it's going to be 2 times, rewrite cos squared as 1 minus sine squared. You might say, sir, why did you do that? I had to do that in order to get an equation strictly in terms of one variable. The one variable is sine x. So now we have everything strictly in terms of sine x. When you have everything strictly in terms of sine x, we can form our quadratic equation. So this will become 2 minus 2 sine square x, 2 minus 2 sine square x minus sine x minus 1 equals 0. That's what we get. Now look at this now. This becomes minus 2 sine square x minus 2 sine square x minus sine x. And then we have 2 minus 1. Now 2 minus 1 is just plus 1 is equal to 0. Now we never like to solve a quadratic with the coefficient of x squared negative. So we multiply through by negative 1 to get 2 sine square x, 2 sine square x plus the sine of x minus 1 is equal to 0. That's what we get. That is it. Now let us go ahead and factorize. So now we can factorize it. The only way we're going to get 2 sine x right there, 2 sine square x, is if we have a 2 sine x, and this has to be a sine x. Now we know signs are different and the greater product negative, so we have 1, 1, we have minus and plus. The greater product positive, sorry, so this one is plus, this one is minus. This times this is, yep, that's it. So from this side, what we're getting is sine x equal to a half. And from this side, we're getting sine x equal to negative 1. That's what we're getting. Nice. So let's go ahead. Let's go ahead now and do this. So what we're getting is we draw our circle right here for the first part where sine is a half. We want where sine is positive here and here. Then we need to find sine inverse of a half. So we're finding sine inverse of a half, and sine inverse of a half is equal to, sine inverse of a half is 30 degrees. That is 30. Since that is 30 degrees, and we know sine is positive in the first two quadrants, 180 minus 30 is 150. So that means down here, answers for x are x equals 30 degrees or x equal 150 degrees. Easy. Look at this now. Sine x is minus 1. If sine x is minus 1, you draw your circle for that one. Where is sine negative? Sine is negative down here. Find sine inverse of 1, and sine inverse of 1 is going to be 90 degrees. Sine inverse of 1 is 90. That's 90 degrees. So we need 180 plus 90, which is 270. So in the third quadrant, it's 270. And 360 minus 90, which is still 270. So that means from this side, x equal 270 degrees. And those are the solution. So x equal 30, x equal 150, x equal 270. Easy, soft, a capital T. Nice. That concludes solving these trig equations when it is in degrees. All right, this question says, by writing sine 3 theta as sine 2 theta plus theta, show that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. To do this proof, what we need to do is follow instructions. So start with your left-hand side. Your left-hand side is equal to sine 3 theta, sine of 3 theta, and sine 3 theta, they say you need to break it up as sine of 2 theta plus theta, because 2 theta plus theta is 3 theta. So what we're going to do is use compound angle formula. Using the compound angle formula, this is now equal to, using compound angle formula, this is now sine 2 theta. This is now sine 2 theta times the cos of theta plus, this is now the cos of 2 theta, cos of 2 theta times the sine of theta. Then what do we need to do now? What we need to do now is rewrite the sine 2 theta and the cos 2 theta in terms of sine. But sine 2 theta, remember, is 2 sine theta cos theta. Sine 2 theta is 2 sine theta times the cos of theta. That's sine 2 theta. So we get 2 sine theta cos theta. But then we have 2 sine theta cos theta, and it is being multiplied by cos theta plus, so that's this part right here, plus, now cos 2 theta can be broken up as 1 minus 2 sine squared theta. Nice. That is 1 minus 2 sine squared theta. And this is being multiplied, of course, by the sine of theta. So what is going to happen? What is going to happen is this works out now to be 2 sine theta cos theta times cos theta. The cos theta times the cos theta becomes cos squared theta. Cos theta times cos theta becomes cos squared theta. So we get 2 sine theta, and then cos theta times cos theta is cos squared theta. Let's cos squared theta. Then we have sine theta times 1. That becomes plus sine theta. And then we have now sine theta times minus 2 sine squared theta. That becomes minus, that becomes now minus 2 sine cube theta. Minus 2 sine cube theta. Now look at this now. Now this cos squared theta, cos squared is 1 minus sine squared, because we want everything in terms of sine. So it's going to be 2 sine theta times the cos squared theta can be rewritten as 1 minus sine squared theta. That's now 1 minus times sine squared theta. And remember, we're adding a sine theta. So we have our sine theta right there plus sine theta. And then, of course, we're subtracting minus 2 sine cube. So minus 2 sine cube theta. So now what is that going to be equal to? This works out now to be 2 sine theta times 1, which is 2 sine theta. This is 2 sine theta. Then we have 2 sine theta minus sine cube. That's minus 2 sine cube theta is minus 2 sine cube theta. And then we have plus the sine theta, plus the sine theta, and then minus sine cube theta, minus sine cube theta. That's what we're getting. Nice. So what this works out now to be is 2 sine theta plus sine theta is 3 sine theta. So we get 3 sine theta. This works out to be 3 sine theta. And then as we can see right here, the minus 2 sine cube and the minus sine cube. Minus 2 sine cube. Let's see, what are we supposed to get? We're supposed to get 3 sine theta minus 4 sine cube. Oh, this was minus 2 sine cube. Coming from here, minus 2 sine cube. So we have our minus 2 sine cube minus 2 sine cube. That's now minus 4 sine cube. So now the proof done. We get 3 sine theta minus 4 sine cube theta. And that's it. That's equal to your right-hand side, and the proof is finished. Soft. This is now our right-hand side. So again, the trick, first thing, rewrite sine theta as sine 2 theta plus theta. Then expand it using the compound angle formula sine 2 theta cos theta plus cos 2 theta sine theta. Then rewrite sine 2 theta as 2 sine theta cos theta times the cos theta plus rewrite cos 2 theta as 1 minus 2 sine square theta. Then you expand it to get 2 sine theta cos square theta plus sine theta minus 2 sine cube theta. And then you change the cos square theta to 1 minus sine square theta to get 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube. Then the 2 sine theta plus the sine theta give you 3 sine theta. And then the minus 2 sine cube minus 2 sine cube is minus 4 sine cube. Then that give you your answer. So do the first part. Nice. Proven. Now it says, given that sine theta is root 3 over 2, find the exact value of sine 3 theta. It's a given that sine theta is root 3 over 2, find what is sine 3 theta. Now, of course, you're going to use this formula that we just found. So all you're going to need to use is that sine 3 theta, sine 3 theta, this for part B, sine 3 theta is equal to sine 3 theta is 3 sine theta, 3 sine theta minus 4 sine cube theta. Or you can write it this way as minus 4 times the sine of theta. This is really the sine of theta, and it is all being cubed. All being cubed. So now remember they tell you sine theta is what? The sine of theta they give you is root 3 over 4. So then sine 3 theta is going to be 3 times root 3 over 4. So it's 3 times root 3 over 4 minus 4 times root 3 over 4 cube, root 3 over 4, and that is being cubed. So now all we need to do is work this out. So what this works out to be is, just put that in your calculator. Let me see. This is 3 root 3 over 4. 3 root 3 over 4 minus now root 3 cube. Root 3 being cubed is what? Root 3, and I cube it. Root 3 cube, I know that is root 3 squared times root 3, which is another 3 root 3, and then 3 root 3. Let me see, 3 root 3, yeah, 3 root 3. Now I multiply 3 root 3 times 4, that is minus. And a 4 will cancel out. 4 cube is 64. And I can write that as 4 squared times 4, and a 4 cancel a 4, so over 16. So I get minus 3 root 3 over 16. So it's 3 root 3 over 4 minus 3 root 3 over 16. You may simplify it and write it as one fraction if you wish, but I'll leave it right there. All right, you can just write it as 1. All right, because we could simplify this by saying this is 12 root 3 over 16, and then 12 minus 3 is 9. So the final answer would be 9 root 3 over 16. That's the final answer. So let's write the final answer up here. The final answer is 9 root 3 over 16. Easy, soft. That's how we take on this question. right, let's move right along now.